Welcome. In this video, I'm going to be talking about the truth tables for conditional and biconditional statements. All right, let's just jump right in with the conditional. That's an if P, then Q statement. Or sometimes I say P implies Q. All right, so in order to construct this truth table, since we have two simple statements, P and Q, I'm going to need 4 rows. One for P, a column for P, a column for Q, and there are 4 possible combinations: true, true, false, false, and true, false, true, false. So now let's think about what this means for P implies Q. So to help us figure this out and make sense of it, before I fill in the values here, I want to think through an example. So if, let's say, I'll say if you pass the final, or I'm sorry, as far as the simple statements, I shouldn't include the if there. So the simple statement P would be you pass the final exam, and Q would be you pass the class. Okay, so, and then the if state would mean if this, then that. So let's consider the first row here. This is where both of these statements are true. You pass the final, you pass the class, and so is it true when I say if you pass the final, you pass the class? Well, I have been truthful in saying this. You did take the final and you did pass the class. So it sounds like that this if-then statement is true. And in fact, it is. Now, what if I tell you, if you pass the class or pass the final, you pass the class, and in fact you do pass the final, but you don't pass the class? Will you judge this to have been a true or false statement? Well, sounds like that'd be false then. Now, the last two here are interesting because in both cases, the first statement has a false truth value. So you didn't pass the class. Now, in the first one here, you didn't pass the exam. And in the second one, you also didn't pass the class. You didn't pass the exam. So will it be true to say, if you do pass the final, you will pass the class? So it's interesting to know that as far as evaluating the conditional statement, that when the first simple statement, we call that the antecedent, by the way. This is called the antecedent, and this is called the consequent. When the antecedent is false, it doesn't really matter whether the consequent is true or false. It's still considered to be a true statement. So if you didn't pass the final, then I don't really have any way of saying, whether that, affected you passing the class, because you didn't meet the first condition, and so I really can't say what will happen. So it's like you give it the benefit of the doubt and say that it's true. So the conditional statement, notice, it's only false in this scenario. So it's false only when that's the antecedent is true and the consequent is false. So it's this combination that gives us the false. Everywhere else it's true. All right, so now let's consider the biconditional. So this is the statement P if and only if Q. So it works both ways. P implies Q and Q implies P. And so our truth table, we're going to need a column for P and a column for Q, of course. And let's fill in the different combinations and think about when this is true, when it's false. So it's got to be a two-way street. Now, I thought it was going on. Sorry about that. So, one way to think about this is that the biconditional says that this is true and this is true. So we could, we know how to evaluate this. P implies Q. That says that's true, false, true, true. Let's think about the reverse. Q implies P. So remember, this is only going to be false. Now, in this case, when Q is true, and it's only going to be false when Q is true and P is false. So when Q is true and P is false, that's here, then this conditional is going to be false. Everywhere else it's true. Now, as far as this AND statement of P implies Q and Q implies P. So this is an AND statement, so both components need to be true for this AND statement to be true. So here I have both true, but not in the next, but again in the last. Now, as far as my component simple statements, P and Q, notice that this P if and only if Q, it's true when P and Q have the same truth value. So the P if and only if Q is true whenever P and Q have the same truth value. In other words, they're either both true or both false. Otherwise, it's going to be a false statement. All right, so those are the truth tables for, and again, maybe I should have written it here just to make sure that this is clear, that this is the truth table for the biconditional, P if and only if Q. All right, I'll see you in the next video.